Last topic of this paper, Runge Kutta method to obtain the solution of a differential equation. Suppose this is the differential equation dy by dx is equal to f of x y with initial condition y x naught is y naught, that is value of y is y naught at x is equal to x naught. Then there are two methods, that Runge Kutta second order method and the Runge Kutta fourth order method. So these are the formulas to obtain the solution of the given differential equation, that y1 is y naught plus 1 half k1 plus k2, where k1 is what, h f x naught. F x naught means f of x naught y naught, and k2 is what, h f x naught plus h y naught plus k1. K1 is this. Okay, so f of x, f0 is what, f naught is what, f of x naught y naught. And then the fourth order formulas are what, y1 is y naught plus 1 by 6, here is 1 by 2, k1 plus 2 k2 plus 2 k3 plus k4, and these are the values of k1. K1 is same to this, that h f of x naught y naught. F of f naught means what, f x naught y naught. Then k2 is what, h f x naught plus 1 half h plus 1 half plus 1 half h, and comma y naught plus 1 half k1. And then what is k3, h f x naught plus 1 half h y naught plus 1 half k2, and k4 is what, h if x naught plus h y naught plus k3, like this, y naught plus k1. So this is the k4, and find the values of k1 k2 k3 and substitute. Here we have the y1. So problems on this. So this is the first problem. Use RK method or Runge Kutta method to approximate y when x is 0.1 and x is 0.2, given that x is equal to 0 when y is equal to 1. That is, we have the value of y0 is equal to 1. That is this is the initial condition. Y0 is 1 means what? Another form of this condition is what? Y in bracket 0 is equal to 1. Means y is 1 if x is 0, and dy by dx is x plus y. So we have to find the value at 0.1 and then 0.2. So we use the Runge Kutta second order method. So Runge Kutta second order method formulas are these. So y naught, y1 is y naught plus 1 half k1 plus k2, and k1 is this, k2 is this. Okay. So we find y1 means value at 0.1, value at 0.1, that is y1. And this is again the same type problem. This problem is also we can solve by using Taylor's methods, Picard's methods, Euler's methods, and Euler's modified method. This is the fifth method, that Runge Kutta method. And all these five methods, that is Taylor's series method, the first one is, then Picard's method, and then Euler's method, third method, and the Euler's modified method or modified Euler's method, fourth method. And this is the fifth method to obtain the solution of a differential equation. So in this chapter, there are 5 methods. Out of these 5 methods, the Euler's method, Euler's modified method, and Runge Kutta method, these 3 methods are important as compared to the first 2 methods, that is Taylor's methods and Picard's methods. So Runge Kutta methods, the formulas are important, and then the value at 0.1. We can solve this problem also by using another 4 methods. So we have to find y1 at 0.1, and x naught is 0, that is the value of x, and y naught is 1, h is 0.1, that is without dividing the interval 0 to 0.1, where the value at 0 is given, x naught is 0, and what is x1? x1 is 0.1, that is we have to find the value at 0.1, and that is y1. So y1, formula for y1 is this. So first, what is y0? y0 is 1, and then 1 half k1. What is k1? k1 is h f naught. F naught means f of x naught y naught. So substitute h as 0.1, and f of x naught y naught, this is f of xy. First here denote that dy by dx means f of xy is x plus y. Here write first f of xy is x plus y. So f of x naught y naught is 0 plus x naught is 0 and y naught is 1. So 0 plus 1, that is 1. And then k2 is what? H f x naught plus h y naught plus k1. That is 0.1. F of x naught plus h means 0 plus 0.1 is 0.1, and then x is 0.1 plus plus this plus sign, y value of y is what? Y naught plus k1. So y naught is 1 and k1 is this 0.1. So 1 plus 0.1 is 1.1. So this is 1.1. And then the answer is 0.12. Similarly, K2, this is K2. Then find Y1. Y1 is what? Y naught plus 1 half K1 plus K2. That is Y1 means Y, the value of Y at 0.1 is equal to Y naught plus 1 half K1 plus K2. 1, Y naught 1 plus 1 half K1 value of K1, K2, and we have this answer. So this is the value of Y at 0.1. Then we have to find the value of Y at 0.2. So start with this value at Y at 0.1. That is, consider this Y at 0.1 is 1.11 as the initial condition. That is, consider this Y at 0.1 as an initial condition. And then we have to find the value of Y at 0.2 means suppose this is Y2. Or again, we denote it is by Y1. And then the same formula that Y2 is what? Y1. Y1. It is Y1 plus 1 half K1 plus K2. And what is K1? Then K1 is what? H f x naught y naught. But x naught and y naught are what? Consider this y at 0.1 is 1.1 as the initial condition. That is, the value of y at 0.1 is 1.11. That is, x naught is 0.1 and y naught is 1.11. There is x1 is 0.1 and y naught is 1.11. And then h is 0.1 because the value at 0.1 is suppose given, and we have to find the value at 0.2 means the h is 0.1 again. And then k1 is what? H f x naught y naught. These are the x naught y naught now, and h is 0.1. Substitute the values. F of x naught y naught is this. F of xy is x plus y. So f of x naught y naught is x naught plus y naught. And then we have this answer. K2 is what? H f x naught plus h y naught plus k1. So x naught plus h is this 0.2, and then y naught plus k1 is this 1.231, and then we have this answer. And then y2 means the value at y at 0.2. So here is the again the same formula that y2 is y naught plus 1 half. Just notation is different. 1 half k1 plus to distinguish the y1 and y2. So here is the notation is different, and then substitute the values. We have this answer. So this is the value of y at 0.2. So this is the answer of this problem. So very simple problems. We have to solve this same problem by using the fourth order formulae, Runge-Kutta fourth order formulae. So write the Runge-Kutta fourth order formulae. These are the formulas. And then we have to find the first y at 0.1. Then x naught is 0, y naught is 1. Similarly do this. X naught is 0, y naught is 1. And because the given condition is y0 is equal to 1. And then k1 is h of x naught, y naught. The formula, then we have this answer. K2 is this. K2, the formula for K2 is this. So we have this answer. And then value of K3 is this, that h of x naught plus h by 2, y naught plus K2 by 2. So we have this. And this, the value of this quantity are 0.05. Value of this quantity is 1.055. And then their addition. Because f of xy is what? F of xy is x plus y. Here is the formula. F of xy is x plus y. Dy by dx, say dy by dx as a f of xy. So here write first f of xy is x plus y. And then we have the answer. K1, K2, K3, K4 are this, and substitute the values. We have this answer. That is y at 0.1. And this is the answer y at 0.1, 1.11 by using second order formula, and by fourth order formula it is 1.11034. That is more accurate. We have more accurate answer by using fourth order formula. Then we have to find y at 0.2, that is y2. Then again x naught is what? X naught is this 0.1 and y naught is this 1.11034, and h is 0.1. And then write find k1, k2, k3, k4, and substitute the values. So the remaining parts are what is missing. So here write K1, find K2, K1, K2, K3, K4, then write next part of this answer, that write this formula. Y1 is y naught plus 1 by 6 K1 plus 2 K2 plus 2 K3 plus K4, and substitute these values. We get the answer. Okay, so that is the value of y at 0.2. So then the next problem is again use Runge-Kutta fourth order method to determine the value of y at 1. And the value at 0 is given. So y0 is 0, y0 is 1, x0 is 0, and we have to determine the value at 1. So we determine without dividing, take h as 1. Value at 0 is given, and we have to find the value at 1. And then find k1, k2, k3, k4. So, and write the formula for y1 as y0 plus 1 by 6 in bracket k1 plus 2, k2 plus 2, k3 plus k4, and substitute the values. So, what is dy by dx? dy by dx means f of xy is y minus x divided by y plus x. So, f of x naught y naught is what? Is y naught minus x naught. That is y naught is 0, 1 minus x naught is 0, 1 minus 0, 1 plus 0. That is 1. Then k3, that is x naught plus h by 2. What is x naught? X naught is 0. H is 1 by 2 means 0.5. This is the value of this is 0.5, comma y naught plus k1 by 2. K1 is this, is 1.5. And then f of xy is y minus x divided by y plus x. That is y minus x divided by y plus x, 1.5 plus 0. Similarly here, the x naught plus h by 2 is 0.5, and x naught y naught plus k2 by 3, k2 by 2, this is k2 by 2 is 1.25, and then f of xy is this. So we have this answer. So this is again the same problem, but we have to find the value at 0.1. Here the same problem, but value at 1. And here we have to find the value at 0.1 and then 0.2. Then first find value at 0.1. So y1 at 0.1 is this, and use this as an initial condition for further calculation. That is dy by dx means this is f of xy. So write in these two problems, right here that f of xy is x plus y. Again, here write first sentence that f of xy is y minus x divided by y plus x. Similar to this, dy by dx is this. So f of xy is y minus x divided by y plus x. X naught is 0. Y naught, y0 is equal to 1 means x naught is 0. Value of y at x is equal to 0 is 1. So x0 is 0, y0 is 1 from this initial condition. Take h as 0.1, and then x1 is 0.1, x2 is 0.2. Then we have to find the value at 0.2, and then y1 means the value at 0.1. This is the formula by using second order Runge-Kutta method. And then k1 is this. So k1 we have this. X naught is 0, 1, and then y minus x by y plus x. This is the formula. And then we have this answer. K2 is this. Okay. And then y1 is 1 plus 1 half this part. Y naught 1 half k1 plus k2 is 1.0917. And then use this as an initial condition. That in the second part. That is what is in this part. What is y naught? Y1. Again the repetition. I think 1 point. Yes. So okay, y2. This is y2. Then what is y2? Y2 means the value at 0.2. So consider this y1 means y0. Y at 0.1. Y at 0.1 is this. Means x naught is 0.1 and y naught is 1.0917. So here is x naught and y naught. Use same formula. Here is some correction. Here is some change in the writing formula. That is use either to determine y2. Here is the y2. Use same formula that y2 is y naught, or instead of y naught and k1 k2 use y naught y1. So here is the y1. Use notation y1. Y1 means the value at 0.1. Then it is this value 1.0917. So same formula, but notations are replace 0 by 1, and then value at 0.2. So similar problem. Take h as 1, and we have to find the value at 0 is given, and we have to find the value at 1. That is h is 1. Dy by dx means this is f of xy, and then write the fourth order formula and find k1, k2, k3, k4 just by substituting the values. X naught is 0, y naught is 1, h is 1. We have to find the value at 0.1, not 0.1, at the value 1. The value at 0 is given, and this is f of xy, x square plus y square by 10. Then write the formula and substitute the values. We have this answer 1.1464. So these are some problems for homework. use RK method, Runge-Kutta methods, and find the values. Okay, their answers are also given. So here the first, the syllabus of second paper, that is the numerical methods and its applications, is now over. So in the next lecture we will start the new paper, that is multivariable calculus, that is paper number 1. So in the next lecture we will see the first topic of the paper number 1, multivariable calculus.